Microplastics are pollutants found in the environment, with sizes ranging below 5 millimeters. It is estimated that half of the plastic products that humans consume turn into trash in less than a year. Not only that, but microplastic pollution is an alarming threat to aquatic organisms. Studies have reported that microplastics are abundant in marine and fresh water. They also affect the quality of the soil and hence the food we eat. Because humans' exposure to microplastics is increasing every day, recent studies have found presence of microplastics in human blood. Therefore, it is necessary to look for techniques that are cheap and easy, using methods that facilitate the detection of these particles. Microplastics is a molecular sensor proposed to detect microplastics in human blood. One proposed method is the pyrolysis one. This semi-quantitative technique quantifies the products of thermal degradation of the plastic particles present in the blood samples. This method was the basis of the proposed sensor. Our proposed sensor involves a substance called Nile red, an environment-sensitive fluorescent dye. This dye can be synthesized by a nitrous intermediate, and it is also possible to have different derivatives of this Nile red which also function as these fluorescent dyes. But how does the method work? The process has three main steps: the alkylation of the aminophenol, the nitrization of the previous product, and the condensation of the desired dye. Once the Nile red is ready, a blood sample is treated according to the monocyte isolation method, obtaining the LDL of the plasma, proceeding to detect alterations, such as lipid accumulation over time and in a concentration-dependent manner. In this case, the microplastics would be detected. This has been proven to be useful to detect and classify microplastics in blood due to the fluorescence of the dye. Comparing our sensor with today's technologies, it is important to mention that detecting the exposure of plastic particles in human blood is an issue that must be taken care of. Before, they had used optical sensors, but they have been not as efficient as the one we are proposing. With the innovation of our sensor, it is possible to detect the type and size of microplastics, such as PET and LDPE. Analyzing the cost of the sensor proposed, it is important that it must be affordable for everyone. As we consider that the cost of the techniques for the detection of microplastics require a high investment, we estimated to sell each clinical analysis in $50. However, it is important to begin with less amount, for instance $10 to $20 for each clinical analysis, so it has an affordable impact in the market. With this sensor, we could prevent health risks caused by microplastics and also bring conscious to the effects of plastic pollution, not only on the environment but on humans too.